Odor is an unavoidable byproduct at every sewage treatment works. Consequently, DSD launched contract number DE/2009/02 in order to enhance the odor containment systems at Stonecutters Island Sewage Treatment Works. The project commenced October 30, 2009. There were several scopes of works under this contract. Firstly, all sewage treatment tanks at Stonecutters Island Sewage Treatment Works were covered by FRP covers one by one to form an odor containment system. The covers were designed with a significantly long lifespan, typhoon resistance, and are easily movable. Secondly, odor extraction ductwork was installed connecting to the odor containment system using an extraction fan forming an odor extraction system. Thirdly, biological deodorization filters were constructed and installed to receive all odorous gas and to decompose it and remove all odorous substances before releasing odor-free exhaust air to the atmosphere. After completion of this major plant installation, all odor gases are fed to biotrickling filters where they pass through 2 layers of bacteria inhabited in the vehicle before being released to the atmosphere. When the odorous gas goes through the layers of bacteria attached to the vehicle, hydrogen sulfide and oxygen become water and sulfuric acid, the latter being neutralized by sodium hydroxide. Before discharging to the drainage collection system, clean air is then released to the atmosphere. Fabrication procedure for FRP covers. Fiberglass reinforced plastic was selected as the material for the covers because of its chemical resistance, high strength and long lifespan. Due to the irregular shape of the FRP covers, the hand-lay manufacturing method was employed for them. A mold was fabricated according to the dimensions of FRP covers. A series of layers of resin and glass fiber were then applied to the mold. After the resin and glass fiber cured, the FRP covers were demolded and a number of factory acceptance tests were carried out before shipping them to Hong Kong for installation, quality control testing and inspection of the FRP covers. The quality control testing included 5 main items: glass content check, load test, soft body impact test, hard body impact test and deflection test. On-site inspection and testing included alignment checking, torque tests for supporting brackets, installation inspection of containment system and air extraction tests. The effective quality control system and on-site inspection tests resulted in a high-quality product and successful installation. Cover installation procedures. After the sewage treatment tanks were cleaned and isolated, supporting brackets and guide rails were installed on the sewage treatment tanks to cater for the installation of the FRP covers, which were lifted from ground level to tank deck level one by one. A trolley was employed to transfer the covers to the installation locations to minimize the time required for manual handling. Cover installation sequence. The first containment system for Tank 43 was completed in May of 2010. The 23 northern side sewage treatment tanks were covered in August 2011. Finally, installation of containment systems for the whole 46 sewage treatment tanks was completed in June of 2012. Odor control enhancement work. DSD launched 2 odor control measures to enhance the control and removal of odor. These additional works included the provision of isolation devices and additional independent odor extraction duct work among and along all effluent drop structures and scum pits for isolating the odor sources generated from these areas and enhancing the odor control during routine maintenance of the sedimentation tanks. The isolation devices were made of FRP and designed to be easily operated and maintained. CCTV installation. A total of 84 CCTV cameras were installed on the covers of the lower and upper decks of the sedimentation and flocculation tanks for monitoring the operation of the scum collection systems. The CCTV systems are gas-sealed and explosion-proof to withstand the highly corrosive environment inside the containment systems. Odor extraction ductwork installation. A series of various sizes of air ductwork were installed in the sewage treatment tank areas in order to convey the foul gas generated from the treatment tanks to the biotrickling filters for odor treatment. Computerized fluid dynamics modeling was deployed to determine the most suitable odor extraction points. Finally, 3 extraction points were selected and located near the effluent side of the sewage treatment tanks so as to form an effective odor extraction system. Construction of piling and foundation. The piling and pile caps of DOU1 and DOU2 were designed to be the foundations for all components in the deodorization systems, including the biotrickling filters, extraction fans and odor duct bridges, etc. The foundation levels of the 36-minute piles for DOU1 and 10-socket H piles for DOU2 were around 30 meters and 60 meters below ground level. DOU installation. The 2 sets of deodorization units, DOU1 and DOU2, have been installed at site. The advanced biological odor removal technology employed, namely biotrickling filters, ensures high performance, lower life cycle cost and lower operation and maintenance costs. These systems treat the odorous gases extracted from the covered sewage treatment tanks. The biotrickling filters were designed to achieve a minimum 99% removal of H2S at concentration up to 20 ppm. The capacity of DOU1 and DOU2 are 58,000 m3 per hour and 54,000 m3 per hour, respectively. This capacity is sufficient to treat all odorous gas generated from the existing sewage treatment tanks, which includes influent upflow structures, rapid mixing tanks, flocculation tanks, sedimentation tanks, main distribution channels, scum pits and effluent drop structures. Test and commissioning. In order to ensure the odor containment system and DOUs have been implemented reliably, consistently, safely and to its high-quality standard, both DOU systems were tested and commissioned separately after completion of installation. The 30-day acceptance test for each DOU demonstrated an H2S removal efficiency of over 99%. Furthermore, 3 air change flow rates and negative pressure exists at all odor extraction points, which proves success in the overall acceptance tests for the containment system. One of the main challenges for this project was to carry out the installation of the odor containment system within the planned schedule, without any disruption to the normal operation of sewage treatment works. Studious planning and effective communication with plant operators not only induced a smooth installation program, but also assured the whole project was completed on time to a high-quality standard. Another challenge faced in testing and commissioning of the biotrickling filters was the fine-tuning of the biotrickling filters. Cultivation of microorganism was affected by the environment of the sewage treatment works and quality of sewage. Thus, all parties including the contractor, consultant and plant operator, spent much time testing and adjusting the biotrickling filters such that the whole system can be operated efficiently and also the operation achieves the goal of conservation of electricity, water and chemicals. Safety was a top priority of our project. All existing sedimentation tanks were defined as confined space areas. During the construction stage, all safety measures were taken for entering confined space areas, including conducting risk assessments, implementing continuous monitoring of the level of hazard gases during the works, setting up temporary ventilation systems and providing comprehensive safety training to workers. In addition, A number of protective measures were taken to protect the environment during the construction phase. Noise levels were monitored during the construction phase to ensure that they did not exceed the set limits. Also, a number of trees were transplanted from the site to suburb area for replanting. Furthermore, close monitoring of the concentration of hydrogen sulfide in the surroundings of Stonecutters Island sewage treatment work every day was implemented during construction of the FRP covers and DOUs in order to reduce the odor impact to the environment and nearby residential areas. The project DE/2009/02 was completed on September 8, 2012. Upon completion, odor escape to the environment has been eliminated and consequently there was a significant improvement in the environment of Stonecutters Island sewage treatment work as well as nearby areas.